All right, here we go. So this is helping the proof. I apologize. I forgot to bring the geometry book home with me tonight. I looked at the proof and figured it out at work. I just can't remember what the name of the triangles were. So I'm just going to go with some generic triangles. This is the proof, but I absolutely did not get the letters right. So you're given this triangle right here, which appears to be an obtuse triangle, but this ends up being what they want you to prove. So it's a triangle ABC, except I know it's not called ABC in the book. So it has side lengths of a, little b, and little c, and you are told that a squared plus b squared is smaller than c squared. And you're asked to prove that c is an obtuse angle. And it gives you a hint. It says, make a new triangle, make it right. The triangle is going to have side length of A. It's going to have side length of B. And I'm talking a little a, little b here. You're going to force that angle to be right. And then when you play connect the dot for the hypotenuse there, well, it's not C anymore. You got to give it a new name. I'm going to call it D. And once again, I know this doesn't match what's in the book, but it's the same basic concept here. All right, so how would I prove this? Now, I'm just going to do a talking proof right here. Obviously, they want you to do a two-column proof. So let's see. Well, if we look at the triangle there on the right, since it is a right triangle, therefore Pythagorean theorem, we could say a squared plus b squared is equal to d squared. Now, we got two statements right there with equations and one inequality. The one on the left is an inequality. The one on the right is an equation. But the one on the left says a squared plus b squared. And it's the same a and b on both triangles. I literally just copied the length of a and put it to the new triangle. I copied the length of b, put it on the new triangle. So when it says a squared plus b squared, either triangle, that's the same value. So if I look at the statement there on the right, it says, if you see a squared plus b squared, you can write d squared. So I'll take this statement right there on the left. It says a squared plus b squared. And on the right, it says, if you see a plus b squared, you can substitute a d squared. So that's what I'll do. I'll substitute that d squared into the inequality there on the left, and I'll make that statement right there. Well, a squared plus b squared is equal to d squared, according to the triangle there on the right. So now my inequality says d squared is less than c squared. Take the square root of both sides, and now it says d is smaller than c. Now look at each triangle. The only difference in each triangle, a is equal to a, b is equal to b, but c and d are clearly not the same size, and now I know the difference between the two. I know that d is smaller than c. Now I'm going to reach back a few chapters and remember that the side opposite the largest angle is the largest side. So if I look at the triangle there on the right, well, let's see, 90 would be the largest angle, and the side that's opposite that 90 degrees is D. Well, the triangle on the left is exactly the same triangle. It has length A and it has length B. It's C that's different. And the statement I just wrote, it says that D is smaller than C. So if it was a 90-degree angle that made side D or length D, then the only way that's going to be smaller would be if the angle that's opposite D would be bigger than 90. And any angle bigger than 90 is an obtuse angle, and that's the proof right there. Now, I didn't write that in two-column proof. This is called a talking proof, where you make a statement. You simply, state to the listener the reason. So you can easily write this into a two-column proof. If that didn't help, ask a question, and I'll give you a different response.